For today's lesson, we will be discussing about series. So we will discuss what is sigma notation and how to expand summation notation. So before we start, let's recall what is a sequence first. So when you say sequence, it is a list of numbers or objects in a specific order and may be generated from shapes or patterns. So we have different kinds of sequences. We have arithmetic sequence, we have geometric sequence, we have the Fibonacci, we have harmonic, and so on. Okay? So again, sequence, these are the list of numbers. For example, it can be 2, 4, 6, and 8, and so on. It can also be 10, 20, 30, 40, and so on. Or it can be 2, 4, 8, 16, and so on. Okay? So for each list of numbers, there is a specific pattern. So for example, for the first one, 2, 4, 6, 8, you're adding 2 to get the next term. For 10, 20, 30, and 40, you're adding 10 to get the next term. And for 2, 4, 8, 16, you are multiplying the previous term to get the next one. Okay, so for each sequence, there is a specific pattern that exists. And we call each number in a sequence as a term. So for example, again, let's say we have 2, 4, 6, 8, and so on. So the numbers 2, 4, 6, and 8, these are called the terms of our given sequence. So 2 is the first term, 4 is the second term, and so on. We also have what we call a series. So a series refers to the sum of the terms in a sequence. So for example, you have the sequence 2, 4, 6, and 8. Now if you get the sum of the terms of this particular sequence, then you are now referring to series. Again, series refers to the sum of the terms of a given sequence. Now series can also be presented using what we call as the sigma notation. So let f of I be an expression involving an integer I. The expression f of m plus f of m plus 1 plus f of m plus 2 up to f of n can be compactly written as, like this one, which is read as the summation of f sub I from I equals m to n. So this one right here is what we call as the sigma notation or the summation notation. Okay? From the word sum. So that means you are referring to the sum of the terms of the given sequence. Again, this is what we call as summation notation, and series can be written as summation notation. Now, what are the parts of sigma notation or our summation notation? So this one right here is what we call as the term. So this refers to the general term of our given sequence. So for each sequence, you can identify from its pattern, you can identify the general term of the given sequence. And then this I here is what we call as the index. So this is just the variable that is used in our general term. This can also be any variable. It can be n, it can be k, and so on. Now this m right here is our lower bound. So this refers to our starting number. So what number should we use for our index? So that is the lower bound. And of course, we have the upper bound or our ending number or ending point. This symbol right here is our sigma notation. Okay, so these are the parts of our summation notation or the sigma notation. And again, this signifies series or sum of terms of a given sequence. Now let's write each expression in sigma notation. Let's say we have this particular series and we have to write it into its sigma notation. So we have 1 plus 1/2 plus 1/3 plus 1/4 up to 1 over 100. Now in writing a series into its sigma notation, you have to identify first what is the general term for our given sequence. So you have to look at the numbers given or the terms given, and you have to identify what pattern exists between the terms. Okay? Are we adding a common number, or are we subtracting a common number? Are we multiplying the terms with a common number, and so on? So in this case, we have 1, 1/2, 1/3, 1/4, and so on. So as you can see, these are fractions. So 1 can also be written as 1/1. Okay? So again, they are all fractions. So our first term is 1 or 1/1. Our second term is 1/2. Third term is 1/3. Fourth term is 1/4. And if I will continue that pattern, that means our 100th term is 1/100. Notice that the numbers in our denominator refers to what number of term they are in our given sequence. Okay? So that means we can write the general term as a fraction as well. Now we have to identify what are we going to put here. For the numerator, as you can see, all of them are 1. So we can just write 1, the numerator of our general term. For the denominator, it constantly changes, but it is the same as the number of term that we are referring to. So that means we can write this one as I. Okay? So if I is 1, then it will be 1/1. If I is 2, then it will become 1/2. If I is 3, it will become 1/3. If I is 100, it will become 1/100. So this means now that this is our general term. Okay? So now let's write the sigma notation. So you write the summation notation here, or the sigma symbol. And then let's write the general term. So we have 1/I. So that means this is the form that we will use in order for us to get the terms here. So since we use I as our variable, that will also be our index. So we have I. Now, what will be our lower bound? Usually, we start with 1. Especially if you're just given terms like this. So if we will see, if we will use 1 as our lower bound, we will get the first term, which is 1. So that means we'll write here 1. So that means we will start with 1 once we substitute here to our general term. Now what will be our upper bound? So as you can see, to get the last term, I should be equal to 100, so that we will have 1/100. So that means our upper bound is 100. Therefore, this is now the summation notation or sigma notation of the given series. So it's now the summation of 1/I from I equals 1 to 100. Next, let's have this -1 plus 2 minus 3 plus 4 minus 5 plus 6 minus up to minus 25. So again, we have to identify the general term here. So you have to be observant with the numbers or the terms that we have. So as you can see, it's just 1, 2, 3, 4, 5, 6, up to 25. So that means this is our first term. So 1 will be our lower bound. And there are 25 terms. So that means our upper bound later on is 25. So this one is our second term, third term, fourth term, fifth term, and sixth term. Now the concern is we have to change the sign. So as you can see, the signs here are alternate. So we start with negative, then it becomes positive, then negative again, and then positive. Now you have to think of ways, how are we going to do it? How are we going to change the signs without changing the values? Because as what we know, if I is 1, we should get -1. If I is 2, we should get 2. If I is 3, we should get -3, and so on. So let's try to identify how are we going to change the signs. So let's say I have 1. If I want it to be negative, I should multiply it with -1 so that I can have -1 as an answer. Now for 2, how are we going to make it still positive and at the same time we still multiply to -1 because we multiply -1 on the first one? So what we can do is we can write -1 raised to 2. If we raise negative 1 to 2, it will become positive 1. So positive 1 times 2, then I will get positive 2. How about for 3? So we have 3 here. Now I wanted to make it negative. Again, we have to multiply it by negative 1. But how are we going to make this into negative? So this can be raised to 3. So I have negative 1 raised to 3 is negative 1 times 3. I have negative 3. Because this should be consistent. So by the way, this one, you can just raise it to 1. Negative 1 raised to 1 is just negative 1. So you have negative 1 here. How about for 4? I want to make it positive. Again, we're multiplying by negative 1. And I have to raise it with a certain number. So I can raise it to 4. So I have positive 4. And last, let's say we have 5. And multiply by negative 1. Because again, we want to change the sign. But then, I have to raise negative 1 to a certain number. So this can be 5. Okay, so I have negative 1 raised to 5 is negative 1 times 5. That's negative 5. Notice that we have the same exponent for 1 and the values here. So these are the same. Okay, now if we will change this into general term, let's write it into general term. So we know we have negative 1 that is constant. We keep on multiplying negative 1. And then we have here 1, 2, 3, 4, 5, which are the i's. And as you can see, these numbers here are just the same with the exponent. So we can write here negative 1 raised to I. Okay, so we can raise again our negative 1 to I so that we can follow this particular pattern. Or if we will just arrange this, it will become I times negative 1 raised to I. Okay, so this one now will be our general term. Okay, so let's write here now the notation. So we have I times negative 1 raised to I. And then our index will be I. Lower bound will be what will be the starting value of I that we use to get negative 1. So that is 1. So our lower bound is 1. And then our upper bound will be 25. So that means this is now the sigma notation of the given series. So it's the summation of I times negative 1 raised to I from I equals 1 to 25. Okay, next is we have a sub 2 plus a sub 4 plus a sub 6 plus up to a sub 20. Okay. So a sub 2 is our first term. A sub 4 is our second term. A sub 6 is our third term. And we still don't know yet what will be our a sub 20. Okay, so let's take a look at these values 1, 2, 3 as the values of I that we will use later on. So if I is 1, then we have a sub 2. If I is 2, then we have a sub 4. If I is 3, then we have a sub 6. As you notice, we all have a for our term. And the only thing that changes are these numbers right here. Now, how are these numbers related with the values of I that we will use? Okay? Again, if I is 1, we have a sub 2. If I is 2, we have a sub 4. If I is 3, we have a sub 6. So as you can see, we just have to multiply I by 2 to get the sub numbers here. So that means we can write here 2I. Okay? So again, if I is 1, we will get a sub 2 times 1, which is 2. If I is 2, we have a times 2 times 2, which is just a sub 4. If I is 3, then we have a times 2 times 3, which is a sub 6. Now, how about a sub 20? So we know we just have to multiply this by 2, so that means I here should be 10. Okay, or that will be our 10th term. So a times 2 times 10 will get a sub 20. So that means again, this is now our general term. So if you will write it as sigma notation, we have a sub 2 times I, then we have our index, and then our lower bound is 1. then our upper bound is 10 because that will give us the last term, which is a sub 20. So therefore, this is the sigma notation of the given series. Last is we have 1 plus 1/2 plus 1/4 plus 1/6 plus 1 over 16 plus 1 over 32 plus 1 over 64 plus 1 over 28. Okay, so let's identify again the general term. So this is our first term, this is our second term, third term, fourth, fifth, sixth, seventh, and eighth. So again, let's refer this as the values of I or index that we will use so that it can help us to identify the general term. Okay, so as you notice, all of them are written in fraction form. By the way, 1 can also be written as 1 over 1. Okay, so that means our general term should be in fraction form as well. Okay, now for the numerator, all of them is 1, so that means the numerator is automatically equal to 1 for our general term. Now let's just consider the denominators. So for the first one, if I is 1, the denominator is 1. If I is 2, the denominator is 2. If I is 3, the denominator is 4. If I is 4, the denominator is 8, and so on. Okay? Now we have to know how are we going to get 1 if I is 1? How are we going to get 2 if I is 2? How are we going to get 4 if I is 3? How are we going to get 8 if I is 4? And so on. So we can just write here I, and then let's have here the denominators. Okay, so I is 1, 2, 3, 4. Let's just write the first few terms. So the denominator is 1, the denominator is 2, 4, and then 8. Notice that the denominators, we're just multiplying it by 2. Okay? So 1, we multiply it by 2, 2, we multiply it by 2, we get 4, and then 4, we multiply it by 2 as well. So we get 8. So that means these are also multiples of 2. So we can write it as into its exponential form. Okay, wherein the base is 2. Because again, they are just multiples of 2. So what we can do is, how are we going to get 1 if the base is 2? What should be the exponent? So this should be 0. Okay, so 2 raised to 0, we will get 1. If the base is 2, how to get 2? The exponent should be 1. The base is 2, how to get 4? The exponent should be 2. And for 8, if the base is 2, the exponent must be equal to 3. Now notice, the exponents are the ones that's changing here now. So we have 0 for the first, 1, 2, and 3. Now if you will relate it to our index, as you can see, we just subtract by 1. Thus, we can now write this as 2. That will be the base for all. And then we have I minus 1. If I is 1, so that will be 1 minus 1, so that will be 0. If I is 2, 2 minus 1, that will be 1. 3 minus 1, that will be 2, and so on. So therefore, this is the form for our denominators. If you will write it now, for the general term, so we have 1, that will be for the numerator because all of the terms here has 1 as their numerators. Then for the denominator, we have 2 raised to I minus 1. So therefore, this is our general term. Now let's write it into sigma notation. So we have 1 over 2 raised to I minus 1. Then our index will start from 1. So that will be our lower bound. And our upper bound is 8. Okay, because that's the last term that we have there. So therefore, this is our sigma notation. So it's the summation of y over 2 raised to I minus 1 from I equals 1 to 8. Now, let's expand each summation and simplify if possible. So we're doing now the other way around. We will be given the summation notation and then we will expand it into a series. First, let's have the summation of 2i plus 3 from I equals 2 to 4. So, in order to solve this, all you have to do is to substitute the value of I or our index into the given term and then simplify. So as you can see, the lower bound is 2. That means we will start with 2 as the value of I, and then we will end with 4 because that is our upper bound. So we have here 2 times 2 plus 3, and then plus. So we will be using addition because again this is summation for after every substituting the index or the value of x, plus, and then we have 2 times 3 plus 3, and then last is 4. So after we substitute, we will add, okay? Because again, this is summation. So just simplify everything. So 4 plus 3 is 7. Plus 6 plus 3 is 9. And 8 plus 3 is 11. Or if we simplify it again, we have 27 as the value, okay? So 27 is the value of our summation notation. Next is we have summation of 2 raised to I from I equals 1 up to 5. So again, all we have to do is to substitute the value of I. We will start with 1 and then we will end with 5. So 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3, 2 raised to 4 plus 2 raised to 5. And then simplify, we will have 2, 4, 2 raised to 3 is 8, 2 raised to 4 is 16, and 2 raised to 5 is 32. Then all you have to do now is to add all the terms. So therefore, we have 32. Next is we have summation of a sub I from I equals 1 up to n. So as you notice, we start with 1, but our upper boundary is n. So that means there's no specific value given to us. So what we will do is, we'll just write a sub 1. So we will still start with 1 plus a sub 2 plus a sub 3 plus a sub 4. Since the upper bound is n, that means this one is continuous up to a sub n. Okay, so this is now how are we going to expand. So it's a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 up to a sub n. Because again, there's no upper bound given to us. And for our last example, let's have summation of square root of n over n plus 1 from n equals 1 up to 6. So as you can see, the variable that we use now is n. So again, it depends on the given, so it's not always I. Okay? But same case, all we have to do is to substitute. So this time, we will start with the value of n which is equal to 1 up to 6. And then we will simplify. So let's write here square root of 1 over 1 plus 1 plus square root of 2 over 2 plus 1 square root of 3 over 3 plus 1 plus square root of 4 over 4 plus 1 plus square root of 5 over 5 plus 1 and square root of 6 over 6 plus 1. And then let's simplify each term. Square root of 1 is just 1 over 2 plus, let's just write square root of 2 over 2 plus 1 is 3 plus square root of 3 over 4. For square root of 4, that can be 2. 4 plus 1 is 5. Square root of 5 over 6. And last is we have square root of 6 over 7. Now all you have to do is to add all of them, and then the value that we should get, estimated value that we should get, must be 2.53. So that will be the value of our summation or series. So that's it for today. I hope you learned something about how to write a series into its sigma notation, as well as how to expand a given notation. And see you next time.